In this video, I'm going to cover managing password-related policy on a system-wide basis. This strategy will apply to the local system. In a previous video, I covered managing account password-related settings on an individual basis, which in some cases is required by a system administrator. I wrapped up the video with changing some of the default password-related settings system-wide. This reduces administrative overhead by applying more reasonable defaults to accounts as they are created, eliminating the need to ensure that settings are manually specified every time. Settings I discussed in the last video resolve some of the issues and slightly improve policy. That's not the full picture. To apply additional improvements, PAM policy can be adjusted. PAM stands for Pluggable Authentication Modules. PAM is responsible for handling authentication tasks. I'm going to keep the explanations pretty vague as far as the general functionality of PAM and only focus on adding the settings needed to implement the password policies. I may cover PAM more thoroughly in a future video. Also note that the examples are performed on Debian-based systems. Red Hat-based distros use different file names. And so before going through the PAM related settings, I do want to point out a setting that can be adjusted globally that I left out from the previous video. And that's the password inactivity period. This is the number of days after a user's password expires that an account will still be allowed to log in. Upon logging in, the user must change their password. Once the timer is exceeded, the user is no longer able to log in and an administrator will have to assist the user with setting a new password. Recall that we can check the settings on an account with the passwd command using the status option. The last field in the output represents the inactivity period. Currently is set to -1, which disables the functionality and will not block the user from logging in and changing the password. This can be managed system-wide with the user add command. In my user administration video, I briefly covered how the defaults can be changed system-wide for all new accounts. To recap, the -D option will display the current defaults. This inactive value right here of -1 means that this is not applied, so the user would be able to log in at any time after their password expired and change it. And so we can change that by running user add. And then the number of days we want to set for the inactivity period. Now that's set to 5. And so if we create a new user, now we can see their inactivity period is set to 5 days. And our user has a 5-day window after their password expires where they can log in and they'll be prompted to change it. Keep in mind that this will not apply to existing accounts. This will only apply to newly created accounts. So you will have to run through and either run a script or something else to manage your other accounts. So it's best to get started with these policies on your system as soon as possible. Now moving over to PAM, I'll implement the password history policy, and Debian systems are managed in the etc/pam.d/common.password file. Rel-based systems are managed in etc/pam.d/system-auth. On Red Hat-based systems, that can be directly edited to change the configuration, but it can also be configured by using the auth select tool, which the documentation notes is the suggested method. I'm not going to go into it and demonstrate it here, but I will provide the commands that you can run to enable password history on a system using auto select. If you run this command on your Red Hat based system, this will use the tool and it will automatically make those changes to the files as necessary so that it's enabled. And then you can also disable with pretty much the same. You just switch that to disable -feature and that will password history. Password history remembers previous passwords and enforces policy so that you cannot constantly reuse the same password, and also enforces some changes to the uniqueness of the password. The PAM PW history man page explains the available options and provides examples of the entries that need to be added to the config. So if you want to check that out to learn more about how this module works and how the settings are applied, you can read about it there. Before I make changes, I'm going to back up the configuration files as we go. And so the first one we're going to make changes to is the common-password file. So I'm going to go ahead and back that up. And then we'll go ahead and edit that. And so here, as part of your first setting, and so first here we are adding the password history module configuration. It's not configured by default, and the type is password. The control is required, and the module that is being added to configuration is pam_pwhistory.so, so that we would all need to specify in there to get this working. And so that's all we need for that line. We could specify module arguments after in this area, as you see here, but we don't need anything right now with that. So what we can do is put the module argument we need to add here to this module to make this work. And just a quick explanation is that use auth TOK allows multiple PAM modules to confirm a new password before accepting it. And so that's all we need here. And so for a quick demo, go ahead and log in as Bob. And then we'll change Bob's password for his current password. And then what I'll enter for the new password is the password that we have currently set. And so now password history is going to keep track and it's not going to let us reuse it. And so we can change those settings, and going back to what we'd seen there, we can pass module arguments right there in the PAM file. And there's also a place where it will look for configuration within a directory within Etsy security. The available settings are documented in the module man pages, as well as the location of the additional configuration files. That covers the basics of applying and enforcing password history. Next, I'm going to move on to a module that provides functionality to help us setting complexity requirements. I checked this on a clean install of Rocky Linux and Fedora 40, and it's already installed and enabled. So this is going to mostly apply to Debian-based systems, as it is not enabled or installed by default. And in order to work with that module, we'll need to install this package. That's libpam-pwquality. And get that installed. And so with that installed, let's go ahead and check out the config now for common-password. And so as part of the install, we can see that it's added a line for us to the configuration file. So it's already given us our type and our control, as well as adding the name of the module, and it's passed the module argument for us. I'm going to go ahead and add a couple more here. I'm going to go ahead and save real quick. I'm not going to demonstrate everything. I'm just going to tick off a few of the standard requirements that are typical. And I'm also going to leave the minimum length kind of short at 8 characters. Just for this demonstration. Obviously 8 characters isn't that great anymore, but it's better than the default length that you get on Linux systems, which is 6. So we'll go with that for now, just for this demo. And just a quick run through these options here. We can provide these different values to determine what type of credit a user gets toward a minimum length. Now, the negative values actually state that each of these are required. So we need at least one, and the U credit is uppercase. O credit is other characters, so special characters. D credits is a digit. And of course, we have min-len for the length that we need for our password. And I'll switch to Bob's account so we can demo this. And that's missing an uppercase. And then I was missing a special character. And so then it complains about the length of it. So I had everything except the right length. And there we go. Now I've got everything that's required as specified. One uppercase, one non-alphanumeric character, one digit, and a length of at least 8 characters. There are also some other default features that are applied as part of that module, such as dictionary checks. So, for example, let's say that we try to change Bob's password to hello23. And so that module is going to check against the dictionary and see that we have that in our password, and it's not going to allow it. I'll leave it to you to review the rest of the configuration and discover what other settings you can change as far as adjusting complexity. And so from here, we're going to move on and check out how to implement account lockout. As another measure of controlling password policy, the PAM underscore faillock module can be configured. Module is included in the libpam modules, so you don't have to install anything extra. In general, PAM modules are stackable and need to be placed in a specific order to accomplish the desired outcome. This particular module's man page has an example of a working config at the end of the manual page. On Red Hat and Red Hat clones, this can be enabled with auth-select, and that is this command right here. And to disable, you would just change from enabled feature to disable features. And to get started, I'll back up our common-auth file. We'll need this statement. And then after the PAM Unix module, we need to place. And so just going back to the options in the man page, just a real short, quick explanation here is we have the pre-auth argument, and that's basically saying check if the user is already locked. Then the auth fail is increment the fail counter auth success, auth SUCC. If the user isn't locked, clear the fail counter. And so that is where those need to be placed within our file. Remember that these two need to be placed after PAM Unix, and this should be placed before. So I'm going to go ahead and save our file. So we could have passed some module arguments there, or we could adjust the config file in etc security. I'm just going to roll with those defaults for our demo. And just a real quick run through is by default, it is going to deny user access after 3 consecutive failed logon attempts. And then from there, by default, it has a policy in place to keep the account locked for 15 minutes and then unlock it if there are no additional failed logon attempts during that time. Another part of the policy to note or setting to note is that it will not apply to root by default. You have to go in and make those changes so that it applies to root accounts. Obviously, that's something to be careful with if you're locked out of the root account. And so you may want to take care when applying that policy. You have to use whatever works best in your environment that's going to fit the policy that you're trying to achieve. And so I will leave that to you to check out. There are pretty thorough explanations within the file. You can also disable that unlock timer so that a user is locked out until an admin goes in and unlocks the account. So we'll just demonstrate real quick how that works. And so we'll change to Bob and fail his password 3 times. And so after 3 failed attempts, now we have a 10-minute timer. And even if I put the correct password in here, still get an authentication failure and I am not able to log in. So if we run the faillock and specify user, going to show us the authentication failures. And if we want to unlock or reset that timer to 0 or to enabled. And now we're clear and Bob should be able to log. And that should get you started with managing passwords and tuning policy. The PAM related topics are not covered very thoroughly, which will probably be covered in a future video. So that's all for this video. If you found this helpful, please like and subscribe. Thanks for watching.